Hey guys, so this is the first practice problem we've got. It's saying to apply a by inspection method for node voltage matrix equations. So let's go up. I don't think this one's too bad once you see how to do it. Does it say anything else we need in there? Then use MATLAB or MATScript. We don't need to do that. We'll just solve it by hand and we'll be fine. So we'll solve it with our calculator. So let's go on up. So first step, number one, ref node. Okay, so where are we putting our ref node? It's already on. Sweet. 2. Assign voltages to nodes. All right, so that's V1, that's V2. So that part's already done. So we're doing pretty good so far. 3. Assign conductances to resistors. So here's our resistors, and we're going to put conductances for them. So this is for the conductance, 1 over 6, 1 over 12, 1 over 6. Okay, and that's how we'll remember conductances. All right, 3, 4 is find conductive matrix. Find conductive matrix. Cool? All right, so remember the conductive matrix is, again, we're going to just start with the nice little matrix there. We're going to fill it in. G11, G22, cool. And then G12, and then G21. All right, that's how I do it. 1, 1, 2, 2, and if there's 3, 3, or whatever, but we only needed 2 for this one. So now we've got that. Now we're going to solve for G11. And G11, remember, is the resistors that are touching the V1. So at V1, we have two conductances. So 2 resistors, but we're going to have 2 conductive values. So we're going to have the first conductive value, 1 over 6, and the second conductive value, 1 over 12, plus 1 over 12. And for both of those, that's going to be times 2, so that's going to be 3 over 12. And 3 goes in one more time, that's 1 over 4. Okay, so that's our first value. And I think that's it for that one. So we're going to do G22, which is our second point. And at this one, we have a 1 over 6. And we also have 1 over 12 going as well. Cool. So that's coming back around. So we've got, again, 1 over 6 plus 1 over 12. And if we look, this is going to be the same thing as above. And so that's going to be 1 over 4. Cool. And then we've got a G12 equals G21. Because remember, from voltage from this to this is going to be equal to the voltage drop from this to this. So the change is the same between the two. So with that, we are going to do, what is the difference between the two? So we have this source, which we don't count. Any resistors? That one. Coming down around the top. So that's 1 over 12. And remember, we always make the 1, 2, 2, 1 minus. So that's minus 1 over 12. Okay? And 1, 2, 3, 4. So that's enough to finish our matrix out. So now we're going to make our matrix, and that's going to be G11, which is 1 over 4. G22, which is 1 over 4. I'm going to close that side. And then we're going to do 1, 2 equals 2, 2 equals minus 1 over 12, minus 1 over 12. All right? And then we're going to multiply this by the current. So let's look at our sources real fast. What do we got for our sources? We've got a 2, a 4, and a 3. So let's look at V1 first. V1 has what coming into it? We've got a 4 coming in and a 2 coming in. And what coming out? We have a resistance here, and we have a resistor here. So we only have 2 coming in, so we're going to add these 2 up. So that's going to be 6. Okay? 6. Remember, ins minus outs. And this bottom one, we're going to have at V2, we're going to have our ins of 3 minus our outs of 4. So ins minus outs equals minus 1. Cool? And this is going to equal, remember that's to the minus 1. I should write that in the problem more often. So A to matrix A to the minus 1 times matrix B. And we're going to do that in our calculator. let's plug this in real fast. Math, sorry, I'm off screen right now. Math A to the -1, matrix B. Let's see what we get here. Boom. 25.5 and 4.5. So that's going to equal 25.5, and that's 4.5 is our matrix there. And so we can look back again. 25.5 equals what? Let's go back through. So we looked here at 6, and that was coming in and out of this node, and we have these two, which were the difference between those. So we're looking at V1, so that equals V1, and then that has to equal V2. That's your voltage compared to the ground, compared to your reference node. 25.5 and 4.5. So that's how you solve the first one on the homework.